want to have any announcements, Frank? Or... Okay.
Mhm.
All right. It sounds like
I'm
we'll just
sorry,
jump
Kurt.
in, Chris.
Okay, sounds good. Thanks everybody for coming. Let me pull up my slide deck. Um, can everybody see my screen?
Yep.
Okay,
Looks
great.
good.
So, this paper is a paper from Ivan Spreitz, Lunar Alignments in Mesoamerican Architecture. I chose this paper for a couple reasons. Obviously, this year is the year for the major lunar standstill, and this is a paper that I've had sitting here on my desk for a long time, but just never really broke into it. I'm a big fan of Ivan Spreit's work, but I've always been a bit of a lunar alignment skeptic for the most part. I probably shouldn't say that on a recording because I work pretty closely with Bill Romaine, who's done a lot of work on the mounds in the northern United States. So he probably wouldn't like me to hear that, but I've always been taught to be skeptical of it because of the very little ethnographic records of any kind of lunar alignments. Even though we have some really great evidence at Chimney Rock and some speculative evidence at the Temple of Ur in Iraq, and things like the recumbent stone circles in the UK. But this seemed to be it took my interest because I know his work and I know what he does, and I wanted to see where it led, and I'm pretty happy with it. So let's jump in. So he starts off with his introduction where he's talking about the study carried out different parts of Mesoamerica and how it shows orientations, civic and ceremonial architecture, which clearly exhibited non-uniform distribution. And this is the language he uses in most of his papers to start off with. Concentrations around certain azimuth values and orientation families, orientation groups. Orientation group defined as a group of similar structures from a similar culture, similar geography, similar period in history, so that you can make some kind of inferences. So the existence of these orientation groups here, where he discusses, are separated by space and time, and their similarities can only be explained by the use of astronomical reference, and we'll take a look at that. We'll also it'll also become evident that most of the orientation groups point to sunrises or sunsets on particular dates. And this is borne out, with the Maya groups and their orientations to certain days on the they're relevant in the Maya calendar, certainly not in our calendar. So this paper claims that his recent research of Ivan and partners Nava Sanchez and Pedro Francisco, who they have several papers out together, demonstrate lunar orientations. So let's jump in. Start with lunar standstills. This is probably a familiar image to most. It's done by Clive Ruggles when he discusses the major and minor standstills from an astronomical, mathematical point of view. The Earth's angle, or the Earth is inclined at an angle of I, which is plus or minus 5.14 offset from the sun, from the orbit of the Earth's. I'm sorry, the Earth's orbit of the sun. And then simultaneously, we have our 23.5 canonical wobble of the Earth on its own axis, which gives us our seasons, which is called the obliquity of the ecliptic, represented here by the Greek letter epsilon. The effect is that the lunar nodes process steadily around the ecliptic at an inclination which can be represented as plus or minus I plus E. So moving ahead, this oscillation along the horizon ranges from a maximum northern and a maximum southern limit beyond the ranges of the solstices to a minimum northern and southern limit and back again over a period of 18.6 years, which is called the lunar node cycle or the draconian cycle. So this image below shows the winter solstices and the summer solstice. I don't know if you can see my cursor, and how the lunar extremes can go beyond the solar extremes on the horizon. And of course, the separation between a major standstill and a minor standstill is half of the 18.61 years, which is approximately 9.3 years. So the changes in declination of the moon can vary between a maximum of positive I plus epsilon and negative I plus epsilon, which is plus or minus 28.6 at the major lunar standstill. So that's actually a declination number. So the declination uh, maximum northern and maximum southern is 28.6 or negative 28.6. Now the minor lunar standstills bounded by the declinations of uh, positive epsilon minus I and negative epsilon minus I, or plus or minus 18.5 degrees, which brings us here to the minor standstills that we're looking at here on the inside. And then just a note, whenever you're looking at the apparent motion of the moon, it's rather complicated compared to the sun, and we have to correct for parallax near the horizon. The actual range of the standstill has a parallax modifier in it. Are there any questions at this point about basic the positional astronomy and what's behind the major and minor standstills?
I've never heard that cycle referred to as the draconian cycle. That's new to me.
Draconic.
Draconic, yeah.
Yeah.
Are you familiar why that's associated, or?
I believe that's a rather old name from certainly from Western tradition, Middle East or Greek, I believe.
Yeah.
Maybe,
There's
but,
several different cycles depending on what you're measuring. So the moon can also have a procession of nodes, and that creates a different cycle. It also can have, there's about 3 or 4 things that affect the moon, and if you measure moon to moon with those things in mind, you have slightly different cycles. So draconic refers to just one of those. I don't remember which one it correlates to.
okay. So coming right out of Ivan's paper, the extremes of the moon determined through the observation of its rising and settings tend to be smaller than those resulting from calculations based on the true standstill declinations. In other words, it can be expected that the declinations corresponding to the directions determined this way will be larger for southern standstills, negative declinations, and smaller for northern standstills, positive declinations. And that is precisely what is observed in our data. And that'll come out when we start actually looking at the data. I just threw a little graphic in here. For those that are newer to Maya iconography and astronomy, here's a picture of the moon. We, of course, see a man in the moon. The Maya saw a rabbit. So here are the rabbit's ears. and its body coming around. You'll always see the moon goddess associated with a rabbit. So here's our moon goddess, and she's sitting with the rabbit and the moon. So Ivan and team measured 305 architectural orientations at 106 sites all across the Maya Lowlands and recorded the relative frequencies of declinations corresponding to the east and west azimuths. As per usual in his work, he takes all this data and subjects it to a statistical analysis technique called the kernel density estimation, which produces these curves that he has throughout most of his work, which shows the declinations versus relative frequency. Now, if we look at these actual peaks, and the peaks are, of course, what we're interested in, because his kernel density estimation takes account of any errors in the data, and the statistical analysis method actually pretty successfully wipes out any bad data. Not to say bad data, but anomalous data. So when we're looking at these actual peaks, this really does represent the declinations of the architecture. So we know that this declination here was definitely the most popular declination to orient your building towards. And when we look at it further, the most prominent peaks like these correspond to solar orientations, which is to be expected. So the Maya oriented their temples to the sunrises, or in some cases sunsets, of the sun on important ceremonial days within their calendar of Tzolk'in. Typically, on our calendar, they fall around February 12th. February 9th is also a peak, but it's certainly not the equinox or anything like that, and it's not even really solstices per se. It's these other days that correspond to important dates in their calendar, having to do with seasons and planting. So those peaks are really accounted for here. But then we have these other peaks that we're looking at. And these two peaks here I have highlighted, the corresponding declinations of negative 27.8 in the east, which is our top chart, and 28.6 to the west. And as we saw on the earlier, in our earlier slides, and what the data pans out here for the time the Maya were building between the early classic and the late post-classic, the absolute values of the declination peaks are pretty much just a little bit smaller than the ideal mean of 28.745 for the major lunar standstills. So these peaks here are oriented towards the dates of the major lunar standstills.
Cool.
Any questions so far? Because this is kind of probably one of our most important slides.
So I
Yes, I
expect
did.
the mirroring, right? But it's not 100% mirrored. So it's
Yeah.
No, it's not. And it never really pans out that way.
and why is that? That's I guess the question.
Well, so, part of it is going to be the horizon, right? The horizon plays a big role in your declination calculations.
Okay.
Not just azimuth.
Okay.
That
So
would
you
be
have a
that,
feature
that's sort of
in
what
Go ahead, Rick.
that's kind of what I would have guessed, but I guess I missed the transition in his paper and in your presentation about uh, uh, buildings are oriented towards an azimuth, and is he just automatically correcting those to orient them to the declination? I don't understand why he would do that. So, is he measuring the buildings
Well,
like a compass building, or is he measuring them against the declination of the potential declination of the moon?
well, what he's really doing is he's measuring the azimuth, and he's using his azimuth, and he's using his horizon altitudes and latitudes to turn horizon coordinate systems into um, declination and right ascension. So in the field, of course, we know that it's easier to measure the azimuths and the altitudes and the latitude and do it that way. And that's pretty much what he's doing. He's
So,
really
so I guess, yeah, where I guess I'm having trouble then is there's a calculation that in my mind is missing. He in his paper he goes through and explains essentially the difference in declination of the sun, and that's 5.1 something degrees, and that's perfectly fine. But when you apply that to a horizon, it shifts. So in our world up here in 33 degrees, it's quite a little bit. It's not 28.5 degrees. It's more like it's more like 31 or 32 degrees, and that's a big difference.
You're talking about azimuth now, right?
Yeah, and I don't see that sort of calculated here.
No, the azimuths will change, but once everything's plugged in and converted to declination, that's when the statistical analysis comes in and takes those declinations.
Okay.
The declinations
I just missed the part.
Really
I missed the part in the paper where he says that, because he talks about the orientation of the buildings.
Yes, and he uses orientations to refer to declinations. Really, he uses those interchangeably. And the reason he doesn't, I would think the reason he doesn't spend much time on that, the mechanics behind it and the equations and the conversions is because he'd be putting that into every single one of his papers. And I think he takes that for a given with his audience. That would be my guess.
Yeah, okay.
Well, one thing that I'm a little confused about is on these declinations east, it's mostly negative declinations, southern declinations, whereas in the declinations west, it's northern or positive. Why is that? I don't quite get that.
I will try to hit on that coming up in maybe a few slides. How about that?
Okay.
So basically what we're looking at here is declination east. We're seeing a southernmost standstill, right? And if we're looking west, we're seeing the northernmost lunar extreme, right?
Yeah, but they kind of look backwards, because if you're looking east, you would expect the southern extreme to be on the on the right side. So it's a little confusing, that's all.
Yes. Understood. We'll get there.
Yep.
So I had a question, Philip. If the ideal mean for the declination is 28.7, and the lunar ones are close, did he do a calculation for the sun's declination to see what that difference might be from the mean declination?
Well, in this paper, his ideal mean is he took he calculated the mean of he calculated the maximum lunar extreme for like the early classic period, and then he did the post-classic period, and he did a mean of those calculations, come up with this number. So this number is meant to convey both temporal and geographic information, for the Maya lowlands during the classic fluorescence and the post-classic continuation of the culture in the Yucatan. So as far as solar mean, he doesn't mention anything like that in this paper.
Thank you.
So he takes all of this data, and here we have late pre-classic, late classic, this is early post-classic. So this is really our periods. So when he says late classic, we could say maybe around 600 AD to 800 AD. Early classic, that's anywhere from like 300 to 500, and then the post-classic period starts, somewhere around, we have the terminal classic around 1100. That lasted about a century, and then we're in the post-classic, and that took us all the way up to, contact. So he has these declinations east and declinations west. Some are bolded, some are not in bold. The bold are declinations that he thinks are more important, basically, or more valid, I should say. So he says the better agreement with the western peaks, as you see there's much more bold in the western orientation, suggests that orientations of this group in the Maya area were intended to record the setting of the moon at its major northern standstill. So we're looking at a setting moon towards the west, and it's going to be setting, it's going to be its major northern standstill. This takes into account the error introduced by the complexities of measuring the apparent motion of the moon. And some of these orientations may in fact refer to the maximum extremes of Venus as the evening star. That is certainly a possibility because Venus's maximum extremes also can go beyond the solar extremes of the solstices. So due to the small differences in their maximum extremes, it's often impossible to differentiate the intended celestial target.
Mhm.
So if you look here, another thing that's going to pop up, we're going to see a lot here that's in Quintana Roo. We're going to see a lot that's in Campeche. There's some sites here in Chiapas, like Palenque and Ixchel. We won't talk much about them. And you'll see why in a little bit. So here's two sites he talks about that are in Campeche. One is Sabana Palitas, and the other is Ixcalumkin. So these are in Campeche. And at both these sites, there's stone sculptures of a seated anthropomorphic figure known as Leve. I'm not good at Spanish, but Levija or Levije, or it means the woman, or in Yucatec, it's Ixnuk. And these are found at both these sites. And it's thought that these images might represent the old moon goddess. So could represent an old seated moon goddess. The cult of this deity would have been consistent with the presence of lunar orientations at both sites. And here, from the previous table, we can see that both of these buildings, the south building here at Ixchel, which is right here, has a looks like maybe an eastern declination that's a lot better fit, and Sabana Pallidus has a western. So the concentration of orientations to major lunar standstills throughout most of the entire Maya region is found in the northeastern coast of the Yucatan Peninsula. And you can't even see all the sites here because if I zoomed in any more, I would have lost Sabana Pallidus and Ixchel, which we just talked about, and I wanted to capture them, but most of these sites are right here around Cozumel or along the coast right here. This was an area where the worship of the goddess Ixchel was very popular during the I put pre-classic there, during the post-classic period. So post-classic, if you know anything about the history of Maya civilization, the pre-classic was very much down in the Petén, large sites like Tikal and Calakmul. But then what we had was what's called the classic period collapse, where all these cities just kind of stopped making records. They were abandoned. And we still don't really have a firm grip of what happened. But the post-classic, these coastal cities here and things like Chichén Itzá, which is right here in the middle, all of a sudden really sprung up and hit their fluorescence. And during that time, we had this cult of Ixchel, which became popular along the coast and on Cozumel. So Ixchel was a goddess who was associated with divination, weaving, pregnancy, childbirth, and medicine. So it's a common opinion that Ixchel was a Maya moon goddess, equivalent to goddess I, which is a young goddess in the post-classic codices like the Dresden Codex. Now, this isn't really a picture that's really shown to be God I. I mean, there's much better ones. The reason I chose this is from the Dresden's lunar table or eclipse table. Often you're here, Ixchel is like a suicide goddess of hanging. Here we actually see this young goddess is hanging from a sky band. I think this is a keen sign, which would be sun. This is Akbal, which is darkness. But here we have the young goddess. And she was really associated with Ixchel and the moon. However, Carl Taube, in his 1992 work on major gods of the Yucatan, argued that Ixchel instead corresponded to what Shelley has called the old goddess or goddess O in the codices and has no correlation to the moon. Although her attributes included water, divination, weaving, pregnancy, childbirth, and medicine. Here we see the old goddess. She has a snake on her head. Incidentally, the word for sky and the word for snake are both Khan or Chan. They are homonyms, so you often see the sky and snake used interchangeably. So we have a sky band over here. We have a serpent, which is a homonym for the sky on her head. We have this jug of water, which she's holding upside down and pouring it out. That's how she's often seen in the codices, emptying this water jug. Her attributes include water, divination, weaving, pregnancy, childbirth, and medicine, which is very similar to what we see up here with Ixchel. Eric Thompson, who's a very famous archaeologist and expert in the Maya region in the middle of the 20th century, did a lot of great ethnography and archaeology that was groundbreaking. He said that though there's no direct evidence that Ixchel was a moon goddess, she must have been a lunar deity based on her other attributes. Now, Susan Milbreth, if anybody's familiar with her, she's a leader in Maya um, astronomy and celestial iconography. She argues that the young goddess and the codices and the old goddess are just different phases, different lunar phases, that the young goddess refers to the waxing lunar phase and the old goddess responds to a waning lunar phase.
Age.
Any questions on any of that? Yeah, I picked this up out of Wikipedia on the cult of Ixchel. In the early 16th century, Maya women seeking, um, fruitful marriage would travel to the sanctuary of Ixchel on the island of Cozumel, the most important place of pilgrimage after Chichen Itza, off the east coast of the Yucatan Peninsula. There, a priest hidden in a large statue would give oracles. And we'll come back to that. But here's just a modern day recreation on the Yucatan Peninsula of Ixchel. So this slide, this was next in his paper. I wanted to put it where it fell in his paper, but I kind of disrupts my flow a little bit. But due to the celestial mechanics, full moon extremes always occurred near the solstices, when the sun also reaches the extreme point of its movement along the horizon. But an interesting contrast can be observed. The full moon reaches its northerly extremes always around the December solstice, when the sun rises and sets at its furthest southerly point, whereas around the June solstice, when the sun attains its extreme northerly rising and setting points, the full moon rises and sets at its furthest southerly points. Since the full moon always rises approximately at sunset and sets at sunrise, this means that the extreme positions of the sun and moon are observed on diametrically opposite sides of the horizon.
Mm-hmm.
So if he's talking about watching to the west, so the west, if we're looking west at December, right, we're going to see the sun setting at its lowest southerly point and the moon setting at its most northern extreme. Any questions? Okay, so the first site that he talks about in the paper in any detail is San Gervasio. And this is a site on the island of Cozumel. This is Ina's tourist map that I pulled out just because the paper didn't have a really good map of the entire site of San Gervasio. And he's talking about groups 1, 2, and 3, and 4 all the time. And only puts a map of 4 in there. So I thought we'd get a more holistic view of the site. He does say various sectors of the urban core are oriented to the December solstice sunrise, June solstice sunset, and that this axis is marked by Sock Bay 2 and the parallel Sock Bay 7. So here we have group 1, and here's a blow up of group 1. Sock Bay 2 is this line of orientation. He talks about everything revolving around. We have the parallel Sock Bay up here. Sock Bay, Sock means white, and Bay means road. So Sock Bay was an elevated road made of limestone, so it's white. And here, this Sock Bay here is along this orientation, which is kind of shared by a lot of the structures in groups 1, 2, and 3. Group 4 is not on this map because, as you read in the paper, group 4, which he focuses on, is not really excavated at this point. So, of course, they're not going to let people stomp around it. But it says group 4 in the orientations to the solstices are associated with. This popped up. I can't read it now. With those marking the major lunar standstill. So at San Gervasio, structure C2241A, also called Kanana, na means house. Not sure what kana means. It has a precise orientation that's to the June solstice sunset in the west. It says likely there because we're looking west, oriented west, so wouldn't really be towards the December sunrise. So this structure 2241 is the tallest building at the site, and on top of this building, there's this superstructure, this temple right here, and within the temple there was an altar that was built, and then sometime afterwards, this medial wall was built within the structure. And when the light from the setting sun of the June solstice hits that wall, it produces light and shadow effects, which produce these. I don't want to really use the term sun dagger. I know people cringe at that, but it's really kind of the same argument here that he's using. That these this medial wall and the sun's rays create these lighted areas, and if the altar, they argue, if it supported a statue within this temple, these sun rays would have illuminated any idol sitting on top of this altar, creating a solar hierophany. So Friedel and Sabloff argue that this structure, this Kanana, was actually the temple of Ixchel that contained a talking idol, and is indeed the same oracle temple that was reported by the Spanish that we saw a couple slides ago from Wikipedia, where women would pilgrimage to Cozumel and to speak to the oracle of Ixchel. That very likely was this Kanana. And it had an associated solstitial light and shadow hierophany effect. So here's a map of the Acropolis of Group 4, also called El Romanel, characterized by a combination of lunar and solstitial alignments. And here, from our chart earlier, I just pulled out the one site here that we're dealing with, and we can see that we have our declination, which is kind of a better match here, I think, to the west. Correct? At least we'll see. Both declinations are quite close to the major standstill values. However, the measurements were taken only along the southern wall platform, as this was the only excavated part of the Acropolis. So they used really the only straight line that they had access to. Though the data suggests my orientations to lunar standstills were prominently functioned to the west, recording northern moonset extremes. Structure 54A may have been used to observe moon rises to the east. Yeah, and that's what we're looking at here. Any questions so far? So here we have the El Ramono group function as the original focus of the oracle cult, and the archaeological evidence that was excavated there supports that the site was used as a worship site. The fact that Kanana marks a solar event pointing towards the west at the June solstice sunset does not necessarily weaken its identification as a temple of Ixchel. Sprice talks about the liminal moment in which the sun, the daytime sun, sets on the horizon and transforms into the nighttime sun, which is a very big an important concept in Mesoamerica. And it may have meant to produce this hierophany in support of the power of Ixchel. So one of the things they argue then is that this may suggest that the Ixchel temple with this unique orientation may have been a much older shrine uh, than these lunar maximum orientations, may predate that, and responsible, in fact, for Cozumel's increasing importance from the terminal classic to the end of the post-classic. And then we get to Tulum. Tulum, of course, is on the Yucatan coast, right across from Cozumel. Structures 21 and 25 exhibit different orientations, which can be related to the solstices and major lunar standstills, respectively. I didn't include anything in here in structure 21. I just ran out of time. It didn't really seem as salient a point. But looking at structure 25, here we have on the south side entrance is a stairway that leads up into this room A. Room A has two openings on its east and west walls. It mentions here that the west wall is a little higher. I don't know if you can see it here, but this figure above the doorway is called the diving god. Here's his legs up here and his head, and he's kind of diving or descending downward. So it says for the eastern wall of Tulum structure 25, that the eastern wall divides room A from a much smaller room D, which has two columns on each side. And here we see the apertures of room A, height of the orifice. Okay, and here's looking through the aperture of the east wall of room A. It says the fact that observing from the eastern opening, the visual line through the western opening passes exactly over the western segment of the wall, enclosing the urban core of the site, suggesting the possibility that the two holes served for astronomical observations. The azimuth of the sight line was measured to be 28.658. And they have then assumed that this was actually to be the east-west orientation of the building. And this is equal to the maximum declination of the northern major lunar standstill in the late post-classic period, where a lot of this architecture was built. So this is a pretty good, indication that this building was built to orient towards the major lunar standstill. And to the west, again, as we stated before, most of the evidence suggests that they were looking to the west. In this direction here, the eastern horizon is not even visible. So the idea that the alignment of the two vents in room A had a special significance is also reinforced in its relationship with other architectural elements. So immediately west of the building is structure 29. This is a low platform with a small stairway, whose midpoint is located exactly in the direction marked for the two orifices. So this is further substantiating this orientation. And then extending even further west, the same alignment passes exactly over a small stairway in the west arm of the defensive wall of the city. And it seems significant that this line coincides precisely with the two openings on the east and west walls of room A, rather than with the central east axis of structure 25. So, like I said, I skipped structure 21, but if you remember above the door of room A, we had that central sanctuary with the stucco figure of the diving god. We see the same diving god here in the Dresden Codex. So this is Dresden Codex, page 58. This is a page out of the Lunar Almanac, or the eclipse table. And our diving god here, instead of a head, he has the Maya glyph for Ek, which is the Venus glyph. So the Venus glyph is substituting for his head but he's still firmly within this lunar table. So the fusion of Venus and the lunar attributes, he says, does not come as a surprise, because when we look at the Dresden Venus table, which is a really complex and beautiful piece of archaeoastronomy, it's a table that that really is built around the fact that the five Venus cycles in 8 solar years are commensurate, and it also builds in cycles of the moon and the ritual calendar to make all these 4 completely different cycles all commensurate, and it's really beautifully done. But it just accentuates how closely the moon and Venus were integrated to the Maya. Here we actually see the dissenting glyph tied to the Venus symbol, which is shown iconographically here. So lastly, he says, on the other hand, if the diving deity on structure 25 Tulum refers to eclipses, it should be recalled that the periodicity of both lunar standstills and eclipses depend on the lunar nodal cycle of 18.6 years. So now, orientations to minor lunar extremes. So I highlighted this because when I started down this road, I would have found this this sentence. I would have taken issue with it. I don't know where I stand now, but it says, since the existence of orientations to major lunar standstills is hardly disputable. So okay,
I don't know about that.
so yeah, I think he's making the best argument that I've ever seen that for lunar standstills. But I'll move on. So he asks, is it reasonable then to assume that we have orientations to minor standstills? And now here we see the minor standstills are represented by these other peaks here, these tiny little peaks to the basically to the west. Here's what we'd be looking at. So here's a list of all the sites that they've measured that they come up with viable orientations to minor lunar standstills, and we see again here the ones that they mark as viable are bolded. So again, the majority of them work in the western direction. So the relation of these orientations with the moon is less certain than those corresponding to major standstills, because, as Sprite says, their astronomical reference could have easily been the sun, because the minor lunar standstills are within the range of solstices. And then I would add there that minor lunar standstills are much more difficult for an indigenous astronomer to observe. So I'm just throwing that out there. So the structures in the northeastern Yucatán coast oriented to minor lunar standstills, which do not correspond to any prominent solar group. So these major sites here definitely could not point to a solar referent. We have Nohochna, which is at the site of San Gervasio. We have some structures at Tulum. We have the temple of Kasim. That was a death god at Kalika. And then we have orientations of 2 buildings at Ixchel. One of them shown above. Both correspond to lunar minor extremes, although to opposite horizons, and we can see that down here. This would be the pyramid looking at the eastern direction. And then Etna. Etna, of course, is also on the court on the the coast. Maelstrom talks about this building here known as La Veja, woman. It's not marked on here, unfortunately, but he says for an observer on the pyramid of the 5 stories, right here, the sight line to the building known as La Veja, the woman, or Veja Hechicera, old sorceress, marked the moon set at the major northern standstill. And the orientation of the La Veja building itself orients to the minor lunar standstill, according to Sprice. So it's got a minor lunar standstill orientation to the building itself. It can be used as a foresight for major lunar standstill. According to local legend, at this building, at the base of it, peasants would rest at the base of the La Veja structure and would receive little pocoyo or coconut bowls of water from an old woman in exchange for coins that would leave. And Benavides suspects that this legend is a relic of pre-Hispanic times. If it is, then this may be related to the moon goddess and her aquatic attributes. So I just threw in a picture of the old woman here with her bowl of water because I thought that was an interesting coincidence.
Yeah.
And then lastly, I just wanted to throw this in here. This is certainly not from the paper. I just thought this was interesting as well. Paper from Arnold Leboeuf. This is a chapter in the Handbook of Archaeoastronomy and Ethnoastronomy, where he talks about the cave of the astronomers at Xochicalco. Xochicalco is not in the Yucatán or even in Maya country. This is central Mexican in the epiclassic in between the time of Teotihuacan and the Aztecs. But his work showed that this cave of the astronomers, which was long thought to mark solar zeniths, he argues instead that this is much more likely used to mark lunar maximums. And he uses some iconography from the cave to discuss that. We have the crescent here. Here we have the feathered serpent biting the moon, and some kind of eclipse imagery. So I just thought maybe I'd throw that in there because we do have independent evidence from Mesoamerica that this may have been important. So the cultural significance of lunar orientations. Sprite says the Maya were acutely aware of the many regularities of the apparent motion of the moon, including eclipse patterns. Here's just a couple of pages from the eclipse almanac, where we have these columns counting sets of 177 days. And once they get to a certain thing, then we have an eclipse event that's predicted. This is eclipse imagery. It's almost like it's a white and a black curtain, and we see it here in every one of these images. Here we show a serpent. We have a sun here with the black and white curtain veils, and the sun god with the black and white curtain veil. So all of this iconography is embedded into this lunar table, which is used to predict eclipses and is quite accurate. So it's argued that it's argued in the paper that orientations discussed indicate they perceived periodic oscillations and the extreme rising and setting points, though this knowledge was lost after contact. So the moon was associated with water, earth fertility, and the scheduling of agriculture activities by its phase. Another important point is the aquatic connotations of the moon and its relationship with fertility can be largely accounted for by observational facts. And there's parallels between the synodic month with the moon and tides with the moons and women's menstrual cycles. These were all observable by many cultures in ancient times. And then he mentions that recent research has suggested that there's a correlation between moon phases and rainfall, hurricanes, storms, germination of certain plants, and that there's starting to gather evidence where they think that the certain researchers think rain seems more likely to occur in the first and third weeks of the synodic month. And they correlate this between rainfall patterns and the 18.6 year lunar nodal cycle. I'd have to see more evidence of that before I would weigh in on it, but it's in there. And then finally, he says if associations of lunar and solstitial orientations reflect observation of the standstill phenomena during full moon phases, they can be explained not only in terms of the attractiveness of the opposite positions of the sun and full moon and the contrasting roles of the luminaries due to the shortest, longest days or nights of the year, also in light of their closely related symbolism. So what he's talking about here is basically the hero twin of Popol Vuh. Hunahau here and Ishbalanque, the hero twins at the end of the Popol Vuh story. Hunahau becomes the sun, and Ishbalanque here becomes the moon. So sometimes, the waning moon, like we said, was the waxing moon was viewed as a young goddess, and the full moon was viewed as Ishbalanque himself. And he just calls back, that out to the Popol Vuh. So in summary, the orientations of a significant number of civic and ceremonial buildings throughout Mesoamerica orient to lunar extremes on the horizon. An astronomical target is the most likely interpretation because these declinations occur throughout different places and periods, and the moon is the most likely celestial referent due to the absence of celestial candidates of comparable importance. I would remind him that Venus is almost up there with the moon, but most of these alignments are found in an area which place prominence of the cult of Ixchel on the northern coast of Yucatan. Again, there's some question if Ixchel was a moon goddess. Personally, I believe that she was. The intentionality of orientations to the minor lunar standstills is much less certain, of course. Data suggests that the observation of the full moon extremes nearest to the standstills took place around the time of the solstices. And that's something we see in the American Southwest too, right? That particularly the Hopi, they're looking for full moons around the time of winter solstice and hoping that that's going to show up at the same time, even though it really doesn't. The northernmost position of the full moon approximately coincides with the southernmost position of the sun, and vice versa. And lastly, the significance of lunar interpretations can be accounted for by widespread concepts associating the moon with water, earth, and fertility. And these are all attributes of both the classic period moon goddess and the post-classic period goddess Ixchel. And these concepts originated from observable facts, tides, menstrual cycles, and the weather. And that's it. Just one last picture for those curious. I threw up a slide. There's the Maya calendar, and these glyphs go into detail about position of the moon within its cycle, the name of the moon here in the Gods of the Night series, and this would call out the name of this god. Here we have a D glyph and an E glyph that tells us how many days this moon has been since new moon. Here we have a C glyph that tells us where this lunation falls in a series of 18 lunations. And this tells us its name, and this tells us here with the 10 and the 19 that there was 29 days in this particular month. So they were tracking the moon. And it's interesting to read about them possibly tracking lunar orientations. So that's all I have. Any questions?
Nicely done. Thank you.
Thank you.
Yeah. Thank you, Chris, for taking it on. That's great.
Yeah, I still don't know where I fall on it. I'm much more receptive because I love the author's work. I'll be honest. But again, I was ingrained be a skeptic when it comes to the topic. So I'm interested to know where everybody else feels this falls. I mean, I know Kim's position really well.
Well,
I
I've
can't
done
decide on that statistical plot. I mean, it's compelling. I was trying to think of the null case, like if you just randomly made a random data set and put it on there, you would expect, just a uniform field so that there's clearly peaks, but then like the minor standstill is a tiny peak. So without error bars, I just can't. I mean, it's compelling on one hand, but just I don't know. I think I need to think about it more.
I wish I could speak more to the kernel density estimation statistical analysis process that produces those peaks and eliminates the null. I just haven't gone deep into that yet.
So can you go back to that slide? Because it surprises me that that the solstices do not show up, or they're not as prominent. Did I miss that?
Well, I will. The solstices are not prominent, because that's not what they cared about. So remember are you familiar with like the classic interpretation of E groups in the Maya world?
Actually, no.
Okay. Well, there was one site called Washington where early in the 20th century, researcher noticed that the way that they had a western pyramid, radial pyramid on the western side of the plaza, and on the eastern plaza there was a raised platform, and there were 3 temples on that. And it was reported that from the radial pyramid, if you were looking towards the southern pyramid, the sun would rise above it in the winter solstice, and the sun would rise behind the middle temple on the equinox, and the sun would rise behind the northern temple on the summer solstice. And this spread like wildfire. And then they started finding E groups all over the lowlands. And then they said, well, these aren't astronomically functional because they're just copies of Washington, and they just don't work because they didn't care. They just wanted to make it look like it. Well, that held for just a couple years until they realized that Washington was a much later development than these other sites. So we had 100 years of talking about are they functional or non-functional, until Ivan did the same kind of research but on a much grander scale, not looking at lunar extremes, but looking at E group orientations. And the kernel density estimation showed that these northern and southern orientations to solstices were just coincidental at Washington, and that it wasn't oriented towards the equinox, it was oriented towards quarter day, which marked the halfway point between the solstices, and it really was a one-off. So most of these E groups and most of the ceremonial buildings, like I said earlier, aren't oriented to solstices or equinoxes, which is something that we would think of first, like they did 100 years ago, because it was a very Western centric mindset. But if you put yourself in the Maya mindset, those weren't the important days, right? The important days like I said, February 12th was one of them, and to us that means nothing. But that's where these peaks go around. So yes, right, it's not solstitial, it's not equinoctial, but he argues that it may, these smaller peaks may, here we have, see here we have 1 degree. It's skewed off of
Oh, you,
zero, right?
you're
So if
not
they,
you're not sharing, Chris. Chris,
oh,
I'm sorry,
I'm
you're not
sorry.
sharing.
Let me get back there and how about now?
There we go.
Now you got some.
Down there where it was. Uh, 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 can you guys hear me?
Yes.
Okay. What did I do? Okay. So yeah, so if you see here like the peak, right? If we would expect like an equinox alignment, it would be right here on zero, but it's not. These are on one. So this would be like Washington, where he's oriented at actually a quarter day and not the equinox, which is just a very minute difference, but it's an important concept because they didn't know about the equinox, but they knew about halfway between the solstices. But you're right, the solstices weren't really all that. They were important for sure, but they didn't really point many of their buildings to them. They had more important solar dates that they needed to commemorate, and the dates were so they were actually day pairs, right? So if the sun rises at a point on the horizon, we know it's gonna rise there 2 times a year, right?
Mhm.
Unless it's you're right
Around
at
the
a tropic.
solstices.
But those 2 days he calls day pairs, and day pairs that are separated by multiples of 20 or 13. Those were those were what they pointed to because those were easily manipulated using the Maya ritual calendar, which is 260 days, which is 13 times 20. So yeah, the solstices were far less important than ritual significant days, which, you know, only makes me a little more skeptical about these peaks, but they are there for sure, right?
Yeah. So there's something there.
There's some, yeah. So
Interesting.
of course, there is no culture on the planet that has any ethnographic mention of a lunar standstill, right? That word only came about in the 20th century, and no culture has ever written about it and said this is something that's important to us. And like Ruggles said, one word of ethnography is worth 1,000 orientations. So we've only had a couple of sites. Like I said earlier, there's a temple to a moon goddess at the pyramid or the ziggurat of Ur, which might be aligned to the moon. And they said, well, since it's a moon god, maybe this is, but that's a one-off. And there's a place near Petra where there's a moon god temple with that orientation, and that's also a one-off. And then there's one site in Egypt that they argued maybe. And apart from that, we just have the recumbent stone circles, like I said, um, Bill Remain's work with the mounds in Ohio, and what's his name, who did the Cahokia mounds, who built his work off of Bill's, and then of course, Chimney Rock. So there's not a whole lot of conclusive evidence if you strip away the one-offs and any kind of the lack of any kind of ethnographic support, there's really not a whole lot. And this might be the best argument I think ever made, because we have statistical analysis combined with ethnography and a culture that was indeed watching the moon closely, close enough to know about the 18.6 year cycle. Maybe I don't know yet. I don't know how I feel.
Well, to add to that, I would,
But if anybody,
add the work, Mesa Verde that we did for Cliff Palace and Sun Temple Association there. I think that's a fairly well documented of architecture there that we worked on. And I know for a fact there's a lot going on in Balcony House, but again, it's not well documented or published. And I think that's one of the things that we need to distinguish is that a lot of these sites, especially in the American Southwest, have never been looked at or documented to document this kind of a subject. So that's why part of what we're doing in our landscape survey program is to simply document those kinds of things. And I think we'll find it might be coming out more and more. And as to the ethnographic evidence, I know that that's a huge issue, but I also know, maybe Philip can speak to this, but the Jimmy Rock Lunar Legacy Council, when we came up there too. And a lot of it was, it's coming. It's just a matter of consultation and the right time and the right place.
See you later, everybody. Thank you, Chris, very much. I got it.
Oh, yeah.
Very good.
Well, thank you much, everybody, and
Well, thank you very much for bringing this to our attention. This has been very interesting and nicely done. Thank you.
Yeah, thank you, Chris. It's very clear. Very clear.
Great. Everybody have a good rest of your night.
All right. Thank you all. Thanks.
Good night.
To see
Thank
you all.
you. Thank you very much.
Yep.
Sorry, I missed
Thanks for being here, Phil.
Thanks.
Good
Yep.
night,
Thank you.
Greg,
What?
can I have
What?
can I grab you real quick before we go?
Okay.
we still
Everybody's
recording?
still here, but
Or are we still recording?
oh, wait. Let me stop that. Yep.